Okay, good morning, everybody. Today you're going to have an ALEKS worksheet for homework. Let me turn myself off. So I'm going to pull back the curtain a little bit, and I'm going to let you know what it looks like from the teacher's point of view. So this is actually the worksheet that you're going to work on today, 10 questions involving a bunch of different word problems. The first involves word problems with two unknowns. You've done a bunch of those problems. Two unknowns just means this. Uh, Jay has 5 more marbles than Jack. So Jack would be X and Jay would be X plus 5. And then you go from there. That's two unknowns. So you have a couple of those problems. You will have a couple problems with 3 unknowns. What are 3 unknowns? Joe is 5 years older than Mary, and Sam is 10 times older than Mary. So Mary's X, and Joe is 3 years older, so X plus 3, and whatever it was is 10 times X. You get what I'm saying? So there are 3 unknowns and working it off. I'll give you a consecutive integers problem. And then I'm going to give you some new looking problems involving a mixture. So I'm going to share and I'm going to find where this is right here, a mixture problem. Now, pardon me if I click on the wrong one first. That is the wrong one. Let me go to another one and see if I could find it. There it is. So from my point of view, I can click on a problem and I can click on an example of the problem because I don't know what the exact question will be. They change for everyone. None of you have the same question. But perhaps when you do your homework, or even after you do your homework, you can click on something like this and then click on explanation. So at a city museum, child admission is $550, adult admission is $970. On Friday, 142 tickets were sold for a total of total sales of $1,108.60. How many adult tickets were sold that day? I can click on explanation from my point of view, and it tells me. So first off, there's 142 total tickets sold. So it says, well, let's make one of the tickets X. Let's make the adult tickets X. And we've talked about this on previous examples. Whenever two values add up to something, one could be X. The other value is the total minus X. So the child tickets are 142 minus X. So since the child tickets cost $5.50, that's $5.50 times the 142 minus X dollars right there. The adult tickets, they sold X of them for $9.70 a piece. So that's 970 times X. So then you just make an equation. The child tickets, which is 550 times 140 minus X, plus the adult tickets, which is 970 times X, equals the $1,108.60. If you are not happy with decimals, you can multiply everything times 100 and have no decimals. But you have your calculators at home. You can use your calculators. Take advantage of that. Work out the equation, and here it is. I'm going to leave it up for a second, and you get X equals 78. So the number of adult tickets sold were 78. That's it. Now, if I go to one more share here, I created an equation, and here it is. So I left a lot of blanks here. At a movie theater, child admission is blank, adult admission is blank on a particular day. Blank tickets were sold for total sales of blank. How many blank tickets were sold that day? I'm not going to fill in the blanks. You know what I'm going to say for this question? I'm going to say, watch the video. All right, watch the video. That's what I'm going to say. As far as another example is concerned, what else will I give you? Well, let's see. I'm going to continue along here. Let's go back to this right here. I might give you a word problem that involves rate and time conversion. If I click on this magnifying glass, that's when I get these type of problems. Let's see. Again, I'm going to try. No, that's not it. Sorry, the only way that I could figure this out was if there we go. Oh, no, that's one-step formulas involving DRT. That's the next type of problem. All right, so it's probably this one right here. A copy machine makes 24 copies per minute. How long does it take to make 114 copies? Let's go to the explanation. So, copy machine makes 24 copies per minute. How long does it take to make 114 copies? Yeah, just take 114, divide it by 24, get 4.75 copies. So 4.75 minutes, not 4.75 copies, 4.75 minutes. 0.75 minutes, 3/4 of a minute is 45 seconds. So 4 minutes and 45 seconds. Let me go to my worksheet and I'll actually do a problem with you. A car drives an average of 64 miles per hour. How many miles did the car drive in 4 hours, 45 minutes? So 4 hours, 45 minutes is 4.75 hours, right? Because 45 minutes is 3/4 or 0.75 hours. So if I take my 64 miles per hour, I can multiply it by the 4.75 hours that I'm traveling for. And if I get my calculator out, 64 times 4.75 is 304 total miles. That's my answer. That's it. All right, let's go back to ALEKS. Another type of question I can give you is to solve a one-step word problem using the formula distance equals rate times time. If I click on the not microphone, the magnifying glass right here, let me try to find it once again. All right, let's see if this is it. So here it is, a one-step problem using distance equals rate times time. Diane is running a race. She runs for 17.5 miles at a speed of 7 miles per hour. For how many hours does she run? Let's go to the explanation. Another word for Diane's speed is rate. So if you write out the equation, distance equals rate times time, E equals RT. The distance she traveled was 17.5 miles. The rate at which she traveled was 7 miles per hour, and the time is what we don't know. So take the distance and divide it by the rate, and you get 2.5 hours, or 2 hours and 30 minutes. Let's go back to Microsoft Word. And let's find it. Here it is. A tortoise is walking in the desert. It walks 87.5 meters at a speed of 7 meters per minute. For how many minutes does it walk? So I'm going to write the equation here. Distance equals rate times time. The distance that the tortoise walked was 87.5 meters. I'm going to cross off the word speed and I'm going to write rate instead. And 7 meters per minute, so 7 times t. For how many minutes does it walk? I'm just going to take 87.5 and divide it by 7, and I get 12.5 minutes, or 12 minutes and 30 seconds. Last but not least, what I'm going to give you is the quintessential type of problem right here. Solving a distance, rate, time problem using a linear equation. So let me find that problem here on share and see where I have it. It's probably right here. Here it is. It's what you see on every movie or book about algebra. Two trains leave stations 312 miles apart at the same time and travel toward each other. One train travels at 75 miles per hour, while the other travels at 55 miles per hour. How long will it take for the two trains to meet? Let's go to the explanation. So, train number one, again, you could write distance equals rate times time, or rate times time equals distance. Train number one travels at a rate of 75 miles per hour. Train two, 55 miles per hour. We don't know how long they're traveling, but we do know that they're traveling for the same amount of time because they left at the same time. So distance is rate times time. So the distance for train one is rate times time, 75 times x. The distance for train two is 55 times x. And what we do know is that the two trains, the distances added together, add up to 312 miles. So 75x plus 55x equals 312. And then it's just an equation to solve from there. So 2.4 hours it's going to take for them to meet. So pause this and look at this on the video, because now I'm going to go back to my word problems. And here it is. So for number 4, I left blanks. Two trains leave stations blank miles apart at the same time and travel toward each other. One train travels at blank miles per hour while the other travels at blank miles per hour. How long will it take for the two trains to meet? I'm going to write 2 words. Watch the video. All righty, everybody. Those are the types of questions you're going to get tomorrow at 7:30. An ALEKS homework assignment is going to be posted. Look at this video and use it to help you.